Okay, number 5. First thing I need to do is find the velocity and acceleration for the particle. That's just x prime, that's the first derivative and the second derivative. And then just taking the derivative of each of those pieces, I get 4 times 3 is 12t to the third minus 48t squared plus 48t. Now I'm going to keep going with this. When I find the derivative, I want to factor it as soon as I can because I'm going to need that at some point. So I pull out a 12t and I got 12t times, and I have 12t times t squared minus 4t plus 4, and that comes out to be 12t times t minus 2 quantity squared. So that's the velocity function. Now for the acceleration, I would go back to the unfactored form at the top. That's easier to do derivatives with. So I have 3 times, so it's 36t squared minus 96t plus 48. And once again, even though I'm not asked for it, I want to factor that as quickly as possible, if possible. And so I get 12 times 3t squared minus 8t plus 4 quantity. And once again, fortunately, that factors out to be 12 times 3t minus 2 times t minus 2. And I'm done with part A. Okay, and I'm ready to answer part B. At what values of t is the particle at rest? Well, I gave my statement, even though it doesn't ask for justification there. It's at rest when v of t is equal to 0, and I've already done my factoring, so the answer is just pull right off of the page there. T equals 0, t equals 2, done with B. Now to tell when it changes directions, I have to do more than that. I need a sign test. I have a closed interval from -5 to +5, and I have two critical numbers, 0 and 2. So I find some test values, and I'm going to go back to the factored form. This is easiest when I go back to the factored form and plug in these numbers. Well, the t minus 2 quantity squared is always going to be positive, so really the sign is only dependent on t, and so it's going to look something like that, negative, positive, positive, and we can see that it only changes direction at x equals 0. And that will be only when it changes direction when v of t changes signs. That is only at t equals 0. Okay, so that's part C. The final one, what is the velocity when acceleration is first 0? Well, my acceleration is all factored out, and the values of 0 are, the values of t that make acceleration equal to 0 are t equals 2/3 and t equals 2, and so we're ready to start answering. And we say that a of t is first 0 at t equals 2/3. And we want to find the velocity when the acceleration is first 0. And so we want to find v of 2/3. So you have to think about that carefully. You want the velocity when the acceleration is first 0. Acceleration is first 0 at t equals 2/3, but we need to plug that back into the velocity function. And again, I'm going to suggest that look at the unfactored form. That would be a nightmare, plugging in 2/3 and having to do those powers of 2/3. It's much simpler to plug it into the factored form in this case. So these are little things that are really going to save you time. And so we have 12 times 2/3, which comes out to be 8, times 2/3 minus 2 quantity squared. And 2/3 minus 2 is 2/3 minus 6/3, so that's -4/3 quantity squared. And so we get 8 times 16 over 9, that's 80, and 48, which is 128 over 9. Now in this case, you're not given any units. It doesn't talk about seconds, and you don't know if it's meters or feet or whatever. So it's really you really can't put units on this, and this is an older problem. I think that any newer problems you should expect to find units, and you should use units at this point. But that's the final answer for D. Okay, so I highlight all the answers there, and we're done with number 5.